Hello everyone, welcome back to Maximum Automation. Today in this video, I'm going to discuss the fifth and last principle of Solid, which is the Dependency Inversion Principle. I'll discuss what this principle says and how we can implement this in our framework. So let's first talk about what this principle says. The DI principle is consist of two rules, where the first rule states that high-level modules should not depend on low-level modules. Both should depend on abstractions. And the second rule states that abstractions should not depend on details. Details should depend upon abstractions, which means that high-level modules, which basically contains the business logic, should not be impacted by any changes in low-level modules. So to make it compliant, we need to decouple the high-level and low-level modules from each other. And that can be done by using abstractions. Now let's understand this principle by example. Here in this example, I have the main method in this class, where I have created the employee class object and then assigned the employee first name, last name, and billing rate. After that, it prints the monthly salary of the employee into the console. Now, if I go to the employee class, then here I have these class variables for first name, last name, and billing rate, and one method to get the salary of the employee. Here in this method, it creates the salary class object and then calls the calculate salary method of the salary class based on the employee billing rate. And if I go to the salary class, then here it contains the calculate salary method, which takes the billing rate as an input and then calculates the salary by multiplying billing rate with working hours and number of days of a month. So this is the class structure which I have, and this is working absolutely fine. If I run this, then this is gonna print the monthly salary for the employee Mark Waugh. Here you can see it prints the salary. Mark Waugh monthly salary is $6,000. Though this program works absolutely fine, but this violates the dependency inversion principle, because here the employee class uses the concrete salary class, and therefore it is tightly coupled. Any change in the salary class will break this code. So here this employee class is a high-level module and this salary class is a low-level module. A high-level module is a module which depends on another modules. In our example, employee class depends on the salary class. So employee is a high-level module and salary is a low-level module. So according to the first rule of DIP, employee class should not depend on the concrete salary class, and both classes should depend on abstractions. Now let's see how I can restructure my code to make it dependency inversion compliant. As we know that according to this principle, classes should depend on abstraction. So first I'm going to create an interface for employee class. To create an interface from a class, you can right click on the class name and then go to the refactor. After that, click on extract interface. Here, provide the interface name and then select the members to create an interface. After that, click on refactor. Here you can see that now the employee class implements the iEmployee interface. And here is the interface iEmployee, which is created and declares one method. Now let's go to the salary class. And I'm going to extract an interface from this class as well. provide the interface name and the method to form an interface, and then click on refactor. Now here salary class implements the interface iSalary, and this is the interface iSalary which is created and declares one method to calculate salary. Now let me go to the employee class. Here in this class, I can replace the salary class object with iSalary because salary class now implements the iSalary interface. But this won't resolve the problem. This class still violates the DI principle because it still depends on the concrete class. Now to make it DI compliant, what I can do is I can create a constructor over here, and then I'll add the dependency of iSalary object in the argument. Now let me create a private object of the iSalary interface. And after that, I'll initialize the iSalary object with the object passed in the argument. Now I can remove this line as the employee class doesn't need to depend on the object of the concrete class. I can use the object of the abstraction to call the method to calculate salary. So now this class is DIP compliant because the employee class now does not depend on the concrete class. It now depends on the abstraction, which is iSalary. Now let's move to the main function. And here I need to first create an object of iSalary by using the salary class. After that, here I'll use the iEmployee object instead of employee. Then I can pass this iSalary object into the employee class to initialize the iEmployee object. Okay, so here I made a mistake. I have incorrectly created the constructor. Here you can see I've added the return type to the constructor, but constructor cannot have any return type. Now let's move to the main class again. Here you can see that I cannot set the class variables directly by the object of an abstraction. So I can either create the setter method to initialize the class variables, or I can pass the values directly into the class constructor. So for the demo purpose, let me pass the values directly into the constructor. Here, I'm going to create the arguments for employee, first name, last name, and billing rate. After that, I can initialize the class variables by using the values passed in the argument. Now let me go to the main class, and here I'll pass the values into the constructor. Now, to get the employee's first and last name, I need to create the getter methods, which is going to return these values. So I can go to the employee class, and here I'll first create a getter method for first name, which is going to return the employee's first name. And after that, the getter method for last name, which is going to return the employee's last name. And then I need to add these getter methods in iEmployee interface as well, so that we can access these methods by using the object of iEmployee interface. Now I can use these getter methods to get the first and last name of an employee. So I have changed the structure of my program to make it compliant with the dependency inversion principle. Now this employee class or high level module does not depend on concrete low-level modules. It depends on the abstraction of low-level module. Now, if anything changes in the salary class, then I don't need to come back to this class to update the salary class object. This also complies with the open-close principle. And now if I run my application again, then you can see it worked and printed the monthly salary of the employee Mark Wow. So the benefit of the DI principle is that if in future you need to change the iSalary object with another class, then you can replace it at one place and it won't break the code. Let's say, for example, there is a new class which calculates the salary of an employee by deducting all the taxes. And we want to now print the salary of an employee by deducting all the taxes. So in that case, I can create a new class, let's say net salary. And this also implements the iSalary interface. And then I can implement the interface method in this class. And here, let's say the salary calculated is after deducting the tax. And let's assume the tax is 30% of the salary. Now, if I want to print the net salary of an employee, then I just need to change the object over here from salary to net salary. That's it. My application will work as expected, and I don't need to change my code anywhere else, just only at a single place. And now if I run my application, then you can see that it worked without breaking any code, and it printed the net salary of an employee. So here I can say it is compliant with the second rule of DI principle, that abstraction does not depend on details. Instead, the details depends on abstraction. Here for the demo purpose, I have created the object of different abstraction in the main method. But in your case, you can create another class, which you can say a factory class, which will create the object for each abstraction. So if in future anything changes, then you only need to update it at a single place. So that is the benefit of DI principle. Also, the other benefit of following the dependency inversion principle is that I can use the dependency injection to implement the DI principle. So dependency injection and dependency inversion are not the same. Dependency inversion is a principle and dependency injection is a way to implement dependency inversion principle. So if I use dependency injection, then I don't need to create the abstract objects with the classes. Dependency injection will do this job for us. I'll discuss dependency injection in detail in another video. So this is how you can implement the DI principle. I hope you liked it. Please put your comments in the comment box. Also, please do not forget to subscribe to the channel. Thank you.